Hey there, ladies and gentlemen. So we have been looking a lot at energy the last few weeks, and one of the things that we've covered is conductors and insulators. We did it with electrical energy and thermal energy, right? And we found out some interesting information about conductors and insulators. And the first thing that I want to know is, what is a conductor? Did I hear you? Did I hear somebody say a conductor lets energy flow? I thought that's what I heard you say. So what a conductor does is allows energy to flow easily. Okay? You remember the C? Right? Okay? And then an insulator, on the other hand, does what? I hear you. Who said it? Who said it? Who said it? Yes, very good. This, an insulator, does not allow energy to flow or blocks it. So you remember the lowercase I blocks it, right? Okay. Okay, so for an electricity, when we were doing the electricity, when we were in the lab and we were making those little circuits with the penny and the paperclip and the rubber band and the what else was there? Oh, a piece of paper. Oh, and a popsicle stick. Okay. So, and then we talked about the medium of those, right? We had some wood out there, and we had some metal out there, and we had some rubber out there, some plastic, right? All right. So which one of those were good conductors for electricity? Very good. All the metals. So that aluminum foil, it was good. The penny, it was good. And what's a penny made out of again? Copper. Awesome. Okay. Iron, the paper clip, or the steel, right? All of those made that electricity go off, right? So I have my little, I have my battery, right? And then I have a light bulb. Oops. I have my light bulb, right? And then my copper penny. So this is the penny, right? And this is the light. So what happened with the light when I put all the wires on here? What color are those? Those wires are blue. So I have to attach at the end of the battery, right, to my light, from the end of the battery to my penny, then from the light again to the penny, right? Okay. And so when this happens, my light bulb lights, right? Good job. Okay. Then, thermal energy. What was really good with thermal energy, too? Good job. Metals again. We have all those metals again. So the aluminum foil, the penny, which is copper. Good job. I heard somebody say it out there. Iron, steel. And then remember on the video, the virtual lab we did? Stainless steel. Good job. Somebody was listening. Okay. What else did we talk about that transfers thermal energy, though? We were talking about some hot chocolate or some coffee. Anybody remember that? What were we talking about when we were talking about that coffee? Yes, very good. Good job. Glass. Glass is another one. There's something special about glass, though. Glass does transfer that energy. And this pan has got a conductor and an insulator. Why do we have that insulator again? What's that insulator for? So we don't burn ourselves. Good job. Okay, so our conductors for electrical: metal, thermal. Metals again, and we have glass, because you know when you're touching your car window in the summertime, it gets kind of hot, right? So that glass is a good conductor of thermal energy. Alright, now what about insulators? What were all those good insulators we had? The rubber band. Good job. Okay. The wood. Good job. What about our clothes? Are clothes insulators? Good job. So clothes, especially cotton or wool, those are both good insulators. Okay. The plastic, good job. And then we had this paper, right? We had that paper that was a good insulator that didn't transfer any energy. Y'all remember that? What else is an insulator, though? In your home, in your car. It does get hot, but what does it keep out of your car? Good. We've got that glass again. That's a good insulator for electrical energy. But if you notice, it's an insulator for electrical energy, but it's a conductor for thermal energy. Isn't that cool? I think it's pretty neat. So, when we made our electrical circuit, remember, we had our light bulb. And then we had a rubber band over here, right? And our blue wires. It's got to come out of the end of the battery, right? And go to the light, come off of the light, go to the rubber band, and then come off of the battery, right? Because it's got to go through the battery. Everybody agree? Good job. We've got our plus side and our negative. Good job. And our plus sides can't touch, right? I knew y'all were smart. Now, an insulator for thermal energy. A blanket. Gosh, y'all are so smart. A blanket. And what is a blanket made out of? Good job. Cotton. Or wool. Okay, so kind of like our clothes up here. Okay. The plastic. That's a good insulator again, because we have those plastic cups, right? And then we have wood again. Good job. Remember in the virtual lab where the wood only transferred like 1/100th of a degree? Okay, what else? Rubber. Good job. What was another one they talked about? When we were talking about the blanket, the heat comes from our body and then it stays in the what? Air. Air is an insulator also for thermal energy. Good job. So, again, conductors are going to allow energy to flow easily. Okay? No matter if it's electrical energy or thermal energy. Insulators do not allow the energy to go, or it blocks it, right? Okay? And then we have, for electrical energy, the electrons aren't flowing through the wires. And then for thermal energy, it gets that air in there and traps us, right? So I'm going to draw a little jacket over here. You know those big heavy jackets? Right. It's not a very good jacket, is it? But that's okay. So, here is the rest of your conductors and insulator notes. Okay, so I'm going to put this where you can see that. And I'll pause it. And then here is the thermal energy. Good job.
Okay, so my kids actually